Hey, all right, so welcome to a new series. I'm Hugh Perkins. In this playlist/series, we're going to try playing FlapPyBird using the reinforced algorithm. We might try other algorithms, we'll see. So we've got FlapPyBird on the left. You've almost certainly seen it before. At the moment, it's just playing randomly. It's got a 10% chance of jumping each time step and 90% chance of not jumping. And what we're going to do is we're going to attach a neural network into this. PyTorch, Python, neural network, and we're going to see if we can get the network to learn to play Flappy itself. So in this first video, we're not going to do any coding. We're just going to go over some of the concepts that might distinguish FlapPyBird compared to like VizDoom before it. So let's go. Hey, all right. So this is a follow-up from the previous video for FlapPyBird. So what we're going to do in this video is we're going to take the RL environment FlapPyBird from the previous video, and we're going to add like convolutional network to it. And I'm not sure how far we're going to get, but like we're going to try to actually add some reinforcement learning. We're going to use the reinforced algorithm. We're going to use policy gradients. I think that should be a good fit to this. Now, one thing to think about is in the previous VizDoom reinforcement learning, we didn't care about movement, right? We didn't care where the monster was moving to or anything like that. All we cared was like, we need to sort of point to the monster and that's it. So movement wasn't an issue. Actually, maybe that's why my take cover is failing to train. But anyway, for FlapPyBird, movement is really important because let's say you see the bird here. Right now, does that mean the bird is now falling or rising? Or like just about to bounce? You can't tell from seeing that the bird is here. You have to know something about the past in order to know the future. It's not Markov. Like seeing that picture on its own does not tell you everything that you need to know about what's happening because you can't see the speed of the bird. So somehow we need to tell our neural model which direction the bird is going and how fast. So how to do that? Well, a fairly standard way is we're going to feed the model, the current frame and one or two or three of the previous frames. So the model has access to the last few frames. Using that, it can see, okay, so the bird is falling or it's rising or whatever it happens to be doing. So we're going to need to do that. We're also going to need to so the resolution of this is pretty high. I think we should downsize the resolution a bunch, like without even using anything learned, just by using some sort of like average pooling or something like that, just to reduce the resolution. Maybe not even an average pooling, maybe just some image operation that just shrinks the image. We should probably grayscale it, like I don't know if we need color. And then we'll just take like one or two of the previous frames and then stack them up. So instead of like previously, so we're presenting an image to the network. Each image consisted of 3 planes. The first one was for red, the second was green, the third one was for blue, so like the colors. Now we'll still present maybe 3 images to the network, but the first one will be like 2 time steps before. The second one will be the last time step, and the third one will be like what we see in the picture this time step. And I think if we do that, this stands a reasonable chance of learning. Okay, so basically anything where you can use like muscle memory, policy gradients works fairly well. So FlapPyBird, do you need to have a PhD in maths? No. Do you need to know physics? No. Do you need to practice it a bunch of times? Yeah. So it's this muscle memory. It's just like if you play FlapPyBird lots and lots of times, eventually you'll probably be able to like have a conversation with your friend where you're playing it and you'll score like 100 or something like that. So it's muscle memory. If you can play it with muscle memory, policy gradient should do okay. So I feel fairly confident that we should be able to learn this quite well. So we'll see. So let's go. So let's get stuck into some coding. All right, so that's that for this video, and then in the next video we're going to start some coding, so I might see you there.